Students, welcome to the circle video for the Unit 7 study guide. This study guide is due on Thursday for 11 for A days. That'll be the same day as your test for 11 for A days. And it's due Friday for 12 for B day students. And that would be the same day as your next circles test. Here's a checklist you should follow to get ready for the test. 1, you should have watched and completed all the preview videos. That's your highest priority. I will give you late credit for preview videos for half credit if you turn them in on by test day. You need to memorize that quick reference chart. You need to make sure you complete all the in-class worksheets and check your works. Answers are online. You need to finish the Unit 7 ALEX quiz along with its preview videos. You should finish the study guide at least a day prior to the test. You can have your answers reviewed by the teacher. Also on my website, there's going to be some quick review videos that I will have linked on my website. Let's go ahead and take a look at what should be memorized. This alone, these memorized pages, pages 2 and 3, and then you have the practice pages 4 and 5. That's 10% of your test alone, just memorizing that. That's the first thing you're going to see on the day of the test. So let's take a look at page 6, starting with our circled video problems. I warned you that we're going to be graphing in some form and fashion on every single test. This one's no exception. There's 2 ways to graph. One is using intercepts. The other is using y equals mx plus b. I'm going to show you both. Intercepts. To do intercepts, you start with your template 0, blank, and then your other intercept, which is blank, 0. Now, so here, if you put a 0 in the x coordinate, so come over here in x and just kind of put your finger over it or scratch it out. If we have negative 2y equals negative 4, if we were to divide both sides by negative 2, you would see that our coordinate there is going to be positive 2. Now another way here is we're going to take now and put in the y, put a 0 in the y, so we just say goodbye to that, and that one's easy, x equals negative 4. Now it is possible to get fractions and or decimals here. That's perfectly fine when you do this. You just guesstimate the location there. That is your intercepts. That's both your x-intercept and your y-intercept. Or we can change it to y equals mx plus b. I'm going to do that over here using purple. You start by simply circling the y-coordinate. And you ask yourself, what does it take to get y by itself here? And we're going to go ahead and we're going to minus x both sides. And we get negative 4 minus x equals negative 2y. Again, your goal is to get y all by itself. So we're going to divide by negative 2. And now I'm going to bring it around because you guys are used to seeing y first. So we're going to go y equals negative divided by the negative makes a positive. I have 1/2 x. Double negative makes a positive plus 2. And right underneath, we write y equals mx plus b. We can see our y-intercept is 2, which makes sense because it matches here. And our slope is 1/2. So let me graph first by the intercepts. 0, 2. Is right there. That's 0, 2. Negative 4, 0. Is right here. Negative 4, 0. And if you graph by the intercept, we start at positive 2 on the y-axis, which is right here. Then we have our rise and our run. It's positive, so we're going to go up 1 and over 2. And you can see it's the same line both using intercepts and y equals mx plus b. You should be comfortable with both. Next one. You should instantly recognize that whenever you have three situations, if you have a right triangle, 2, and you have a combination of an angle and a side, a combination of an angle and a side. If you have these two circumstances, you should instantly recognize it as a SOHCAHTOA problem. Yes, we have a right triangle and we have an angle and a side. So we're going to work, you start with SOHCAHTOA, you start by identifying your given angle, which is the 70, and from there we're going to label opposite, adjacent, and hypo. 11 would be your opposite, x would be your adjacent, and this unknown side would be our hypo. So we come over here, have, need, do. Wait for you to catch up here. We have here the opposite side. That's 11, so we write we have the opposite. We want the adjacent side, so we write adjacent. I have an OA combination or AO, it doesn't matter which way you go, and that with an OA combination means TOA. Very, very important. Write out the equation before you do the plugins. So we write exactly the equation, which is tangent of the angle theta equals opposite over adjacent. Put that over 1. Now, circle plug chuck. Tangent of theta, our theta here, you physically pick it up as 70. So we're going to go tan 70. Put parentheses around that. That's a single unit. Over 1 equals opposite. Physically pick it up. 11 over adjacent. Pick it up. X. Now we cross multiply. And we're going to end up with tan 70 times x equals 11. We're not done. Your goal, you don't touch a calculator until x is by itself. Don't touch a calculator until x is by itself. It's not by itself yet. We have to get rid of tan 70 here. So we do tan 70, keep parentheses around that. That's a unit. Okay. Now we have x equals 11 divided by the tangent of 70. X is by itself. So now you may pick up your calculator. So we're doing 11 divided by the tan of 70 on your calculators. So I'm going to do 11 divided by, my calculator is 70 tangent. Make an equal sign. And I get 4.00. Usually I tell you to round to the tens place. Since that's a double zero, we'll just call it 4 up straight up. So here, our x equals 4. Here it says, find the length of the base indicated for the trapezoid. We want to ultimately find the base CD. Now, the minute you see the word base, you should be writing the following equations that include bases, which is the average of the bases equals the median. So we write median equals base plus base over 2. The median equals the average of the bases. Now, very carefully, we're going to circle plug chug. See the word median? Circle it. Come down here, pick up the equation for the median. I'm going to bring it way over here because it's going to be an algebra problem. We need lots of space. Equals base 3x minus 6. Note the plus sign, plus the other base, 37. And then don't forget to pick up that 2. We have a fraction on the right and a non-fraction on the left, so all we do is we put this over 1, and we cross multiply. So we end up with 3x minus 6 plus 37 equals 2 parentheses 4x minus 7. You complete from there. Now realize once you get x, x is not your final answer. You're not just asked to find x. You're asked to find the length of CD. So make sure you show your work. You have to plug that in after you find x and solve. Now number 5, I'm not going to show you how to do number 5, but you want to go back to your Unit 6 video notes. Your Unit 6 video notes will help you with how to do this, your Unit 6 video notes. Or this would be lesson, if you kept your in-class lesson, this is from lesson 6.7. Your Unit 6 video notes would suffice for that. Let's take a look at another circled problem. Okay, it says trace and stretch out the diameters, sweep half circles, sweep full circles, solve for x, and then find all possible arcs and angles. Okay, there's several things you want to look for when you do a squeeze the sponge problem like this. Let me show you the 3 primary things you should be on the hunt for. First, you should be watching out for diameters. So draw a circle, stretch out a diameter. And of course, when you sweep both directions, that's 180. That's the first thing you should hunt for. Now, that's not the only thing you should hunt for. Number 2, when you have circles, the second thing you should hunt for is simply put your pencil on one side, sweep all the way around, and remind yourself that circles total add up to 360. That's the second thing you should hunt for. The third thing you should hunt for is you should simply watch out for vertical angles and sets of vertical angles, remembering that vertical angles are congruent. So under these 3 circumstances, if you're going to have 180, you're going to have something plus something equals 180, or potentially more than 2 somethings. 360, it's going to be something plus something, possibly more, equals 360. And if you have vertical angles, you should be looking for something is equal to something. So you hunt for all 3. Don't be limited to only the diameter, because you may not have one. So let's apply our common sense here. Well, here I do have a diameter, so the first thing I'm going to do is trace and stretch it out. And now we sweep 180. And we could sweep 180 this way as well. Check for both. We see here that these 3 arcs and angles add up to 180. And we learned measure of the angle equals the measure of the arc. So whatever's on the inside is also on the outside. So we can do this. We could say that 52 plus x, that's here, plus 59, which is also out here, plus, here's x plus 91, which is the same on the outside, equals 180. From here, you're going to collect like terms. So underline your numbers and box or circle your x's. Collect like terms. We're going to add over here 52, 59, and 91. Double-digit multiplication, addition, subtraction, division, you should really work on doing by hand. It's good for the brain. So we're simply going to add. 9 plus 1 is 10, plus 2 is 12, carry the 1. 5 plus 1 is 6, plus 5 is 11, plus 9 again is 10. Uh, 20. Okay, so the answer we have here, and we have two x's. So I have 2x plus 202 equals 180. You're going to take it from there. You're going to solve for x, plug x in, find the measure of those angles, and then solve for every potential arc and angle available. Here it says trace the radius and trace the chord, trace segment x, find all possible segments and chords. Okay, so here, radius. Let's trace all radii. Radii go from center to edge. So center to edge, that's 1. Center to edge, that's 2. Center to edge, that's 3. Now we can always draw in extra radii. Keep that in mind. If you don't see a right triangle, you can always draw in extra radii. But we were lucky this time. We already have a right triangle right here for us, so we're going to stay focused just on that triangle. That 42.2 is the entire diameter. So the radius is half of that, so you simply divide that by 2, and you're going to get 21.1. So from here is 21.1. We know if perpendicular, then bisect. There's perpendicular. That means this chord's been bisected. That means this is 17.5. Now we have two sides of a right triangle. We can find the third side, which I'm going to have here in red, nice and bold. Now warning, that red is not x. That is not the length of x. We're going to call that a different variable so you don't get it confused. We're going to call that red y. If we have two sides of a right triangle, we can use the Pythagorean theorem. So we can do leg squared plus leg squared equals hypo squared. Now very carefully circle, plug, chug. My first leg is going to be that segment y, so I'm going to come around y squared plus the other leg, 17.5 parentheses squared equals the hypo 21.1 squared. Now I'm not going to do your math for you. You can solve that yourself, but keep in mind once you have solved for y, you still have to solve for x. That's your ultimate goal, which is this right here. And keep in mind also that from there to there is a radius, that's 21.1. From there to there is a radius, that's 21.1. And very carefully, you should recognize from here to here is a radius. That is also 21.1. Your goal is to just find x, which is that light blue segment. Number 12, finger track, read, and underline. Find the circumference of the circle. Now, the minute you see either the word circumference and area, get in the habit of just writing the equation. The equation for circumference is C equals d pi. Remember, the equation's not just d pi. An equation has two sides with an equal sign. Now, what are we given? We're given area. So immediately you should write the equation for area. Area equals apple pie is really, really good. Okay. Now make note. Do you see the word area? Circle it. Do you see area? Circle it. Since area is repeated, that means these two expressions are equivalent to each other. So I can do this. I can do pi r squared equals 9 pi. Now look, for circumference we need d. Here we're using r. Don't ask yourself, how do I find d yet? Just simply solve for what you can solve for. We can easily solve for the radius here. We want to get r by itself, so we're going to start by dividing both sides by pi. The backtrack of squaring is square rooting, so we're going to square root both sides. And the radius by itself is 3. Now, using that radius, you derive the diameter and find the circumference of the circle. You can express your answer either in pi form or decimal form, but don't forget that your units here, for the area it's miles squared, so your circumference units is going to just be one dimension. So in this case, we're going to go from miles squared to just miles. Don't forget your units. On tests, you'll be marked down if you forget units. It says we're going to trace and frame all inscribed angles, find all possible arc and angle measures. Remember, inscribed angles have 3 qualities. Those 3 qualities are, first off, the vertex is on the circle. 2, the arms are in the circle. 3, the endpoints of the angle, or I'll call them the hands in class, grab an arc. That's an inscribed angle. Head on, arms in, hands grab. Now, knowing that, the first thing you should do when you see any inscribed angles is simply darken the vertexes, because that's where you're going to be framing. And then you just start working with what you can work with. You look for diameters, you look for angles, and we see here that we have a 99, and it's an angle. So if you have Post-its, the first thing you want to do is you want to frame that 99. Frame it up. Okay, an inscribed angle is half the arc it grabs, so this angle here equals this arc it's grabbing divided by 2. The angle is half of the arc. So this 99 here is going to be half of the arc it's grabbing, and it's grabbing this arc like so, from here all the way to here. So it's 99 is half of whatever this was. So to get this on the outside, you simply double 99. So we do 99 times 2. It's 18. 2 times 9, 18, plus 1. And we get on the outside 198. Now, let's look and ask ourselves what else we can find. If this here is 138, and this on the outside is 198, let's find this green arc right here. So we're going to do 198 minus 138, and we get 60. So this green arc is 60. Now, remove your Post-its. Let's see what else we can work with here. We have an inscribed quad. 1, 2, 3, 4. An inscribed quad, opposite angles add up to 180. So these two angles must add up to 180. So if we take 99 and minus 180, notice that's close to 100, so 180 minus 100 would be 80. So this is just going to be 81. Now we have another inscribed angle, so let's frame that 81 here. Okay, the 81 grabs from here all the way to here. So the angle is half of the arc, which means if we have the angle to get the arc, we double it. And if you double 81, you're going to get 162. Now we know from here to here is 100. That means to find this, we simply take 100 away from 62, and we get 162. We get 62. Now, let's see what else we can find here. Now that we have all the arcs, now we can go for the rest of the angles. For example, this angle right here, the green one, I'd like you to frame this one and see what you can find. So that green angle grabs from here, let's come on the inside, to there. That green angle is half of the arc. So first we have to add up 62 and 138. Two plus 8 is 10, carry the 1. That's going to be 7 plus 3 is 10, carry the 1, and 200. So we know this green from here to here is 200. What makes this on the inside 100? Now we can remove the post-its. And one last time, we remember that when you have a quad, these opposite angles add up to 180. So that means back here, if we take 100 away from 180, that means back here, this is going to simply be 80 degrees. Now just double check your diagram and ask yourself, have you found all possible arcs and angles from every direction? And in this case, there's all the arcs have been found, all the angles were found, you're done. So that's how you work these. You used inscribed angles. You should also watch out for diameters. And so this is the facts you're going to use. Let me summarize the facts you should be looking for here. Okay. For these, these are the kinds of things you should watch out for. 1, look for inscribed angles, frame them up. Okay, 2, remember opposite angles in an inscribed quad are supplementary. 3, you should watch out for diameters. And the 4th thing you should watch out for central angles. They might be tossed in there too. So those are the kinds of things you should watch out for in these style of squeeze-a-sponge problems. Let's take a look at 16 and let's see what we can do here. Well, the minute you see a tangent, you should trace it. So this is tangent. I know it's tangent because it touches at one point. That is tangent. This is a diameter. But from here to here is a radius. And you should recognize the song is tangent to a radius, radius, Radius if tangent to a radius, right angle at the edge. So you should recognize that there's a right angle there. Where you have right angles, you should use right triangle stuff. Kinds of things you can use with right triangles. Of course, the main two would be these. One would be the Pythagorean theorem. And two would be SOHCAHTOA. Those are the two things you should be watching out for to see if you can use with right triangles. In this case, we have two complete sides here. We have a leg and we have a hypo. And we don't know this unknown. So when you have two legs, when you have two sides and you need a third side, that one you're going to use Pythagorean theorem. Two sides, third side, Pythagorean theorem. Two sides, third side, Pythagorean theorem. You finish that problem on your own. Okay, for problems like 17 and 18, this is where it's really, really critical, absolutely essential, that you have these, all 7 angles, what they look like, how they can be drawn, and their corresponding equations memorized, absolutely memorized. Now, even though there's 7 angles, there's only 4 equations, because remember, if the vertex is in the same position, such as here, on, same equation. Same position, out, out, same equation. Angle equals arc over 2 for the ons. Angle equals arc minus arc over 2 for the outs. So there's only 4 equations to memorize, even though you have 7 angles. Once you have that memorized, these down here are really easy if you follow these 3 steps. The 3 steps are, first, trace the angle. Step number 2, ask yourself, what kind of angle is it? Identify. Step number 3, write out the equation. Remember, equation has 2 sides with an equal sign. And step number 4, of course, is circle, plug, chug. Do physical pickup. Okay, let's take a look at 17. First, trace it. I see here, this is a tangent, and this is a tangent. So I identified, there I traced it, I identified it as a tan-tan. Notice the vertex is out, so I write my equation for a tan-tan angle. It is angle equals big arc minus little arc over 2. Now, very carefully, circle, plug, chug. I circle angle. I come over here. I don't have the angle. That's my unknown. So I'm just going to call it a question mark here. Equals big arc, circle, trace, physical pickup, minus, I don't have my little arc. How can I work this problem if I don't have my little arc? Physically trace the little arc. There's a blank there. Don't forget to pick up the 2. Now, I'm not going to do your math for you, but what I am going to suggest you do is when you're missing something, always just start by physically tracing the diagram. Go like that. Trace around. Do it again. Start at P, go all the way around, and ask yourself, circles add up to how much? If you know circles add up to 360, you should easily be able to find that small arc, which you're going to do, and then plop it into your equation right there and solve for the missing angle. Again, same idea. We're going to first start by tracing. So I trace. That's a tangent. I trace from here, that is a piece of a chord. So I know my type of angle, I have a tan chord. Notice the vertex is on the circle. You should recognize anytime the vertex is on the circle, the equation is going to be this. It is angle equals half of the arc. It's facing half of the arc. So I come around here, and we are told here that we have the angle. The angle is 35. Circle it. 35 degrees. We don't know this arc, the blue one. So first we're going to find that blue arc. It's arc over 2. So I simply put this over 1, cross multiply, and I find that that blue arc, the measure of that blue arc, of course, is 70 degrees. Now we're not done yet, because we're not asked just for that arc right there. We are asked for this arc going this way. I'd like you to trace it. Go back and sweep the blue arc. Now go back and sweep the green arc and the blue arc together. Now you should be able to find that green arc quite easily. Find the green arc, and you will be done. Circle equations. Equations of a circle are the easiest thing in the world. The first thing you want to do with all of these is always simply start by writing the equation out, which we're going to do here. It's x minus h squared plus y minus k squared equals radius squared. That's the first thing you do, is you write your equation out. No matter what you have, just write the equation out. Now, very carefully, we're going to try to find the h, the k, and the radius. Remember, the h and the k is the center of the circle. So here's our h, and there's k, and then the radius, of course, is just the radius. So take a very close look here. Our h, the original equation is minus h, so the only way we could flip that sign is if that 1 there was originally negative. So our h is negative 1. Our k here, again, notice the sign swap, so our k had to be negative 1 as well. And we have r squared equals 16. So r squared is the square root of 16, which is perfect, so it's just 4. Now, if it's not a perfect, you just get a decimal and then you guesstimate, and that's perfectly fine when it comes to graphing. We start to graph. We graph the center of the circle, which is negative 1, 1. So over 1, down 1. That's your center. Negative 1, negative 1. And our radius is 4. So we go from here up 4, 1, 2, 3, 4, put a dot. Right 4. 1, 2, 3, 4, put a dot. Down 4, 1, 2, 3, 4, put a dot. Left 4, 1, 2, 3, 4, put a dot. Use that to sketch your diagram. Perfect circles are not necessary, as long as it looks circle-ish, and your radius and your center's in the correct spot, you're good to go. Says, use the information provided to find the equation of the circle. Once again, the first thing you do is simply write out the equation. And that's x minus h squared y minus k squared equals radius squared. Now you look at your given information. This one's easy. We are given our h, negative 16. We're given our k, which is -3, and we're given the radius, which is -2√2. So we plug stuff in. Now sometimes you might be given the circumference. For example, if you're given the circumference, let's say the circumference is 20 pi. Your goal is to find the radius. So all you do is you write the equation for circumference, which would be d pi, and you recognize the diameter is 20, therefore the radius, if you had something like this, the radius you'd simply derive as 10, and you'd work from there. So be careful, you're not always provided the radius. Sometimes you have to derive it from, let's say, the circumference or the area. What's the trick to this? Write the equation out. Not rocket science. Always write your equations out. Okay, let's do our circle plug chug. So we have x minus, you pick up your h, which is -16, plus y minus, pick up your k, which is -3, equals the radius squared. So that's 2√2 squared. Now all we do is that's called the plug. You plug stuff in exactly as you see it. And the last step is to clean stuff up. What I mean by clean up is you just take care of the double negatives here. We take care of the double negatives, and then we simply square this. So our final answer is going to be x double negative, so that's going to be plus 16 squared, y double negative plus 3 squared. Now to do this, just pull it out longhand. Let's do this over here. 2√2 times 2√2. Write that down. If you don't know how to square this, just simply write it out longhand. Put that in the margin. Now we multiply outies and multiply innies. 2 times 2 is 4. Root times √2. √2 times √2 is just 2. So 2√2 squared is simply going to be 8. And you are done. That is your final answer. There's nothing else to discover with that. Remember, students, it is very, very critical that you have these 2 pages memorized. Pages 2 and 3 memorized. These problems, the word problems, you work on your own. You'll have a little bit of class time to work on those the day before the test. You'll get some help in class, but you should do the best you can on your own, and then they can be checked in class.